All right, I'm going to see if I can knock out the rest of this 8.1 in the next 30 minutes. All right, so I stopped at number 22. I'm just going to do the odds now, although you should try and do the evens also. Number 23, the sequence is n squared e to the negative n. And we're trying to figure out if this converges or diverges. So I need to figure out the limit as n goes to infinity of, I'm going to rewrite this as n squared over e to the positive n, just using the fact that negative n drops it down. I realize that both of these go to infinity, so I get infinity over infinity. So what I will do is I will transform this first into a real valued function, and that way I can use L'Hopital's rule to take the derivative of top and bottom separately, which will give me 2x over e to the x. And that still goes to infinity over infinity, so I apply L'Hopital's rule one more time. I get 2 over e to the x, and then now the top is fixed, the bottom goes to infinity, this goes to 0. Therefore, this limit goes to 0. So that sequence converges to 0. All right, for the next one, we have a sub n is cosine squared n over 2 to the n. And so as n goes to infinity, cosine oscillates, jumps around between -1 and 1, and it, a bunch of things in between there too. And then when you square it, that means everything that was negative is now positive. So the top is just kind of jumping around through positive numbers, but the bottom is going to infinity. So what I'm going to use here is a squeeze theorem. I'm going to first place cosine n between -1 and 1 because I know it's definitely between -1 and 1. And then when I square it, what I can say is that this has to be less than or equal to 1, but this now has to be greater than or equal to 0 because anytime you square something, it can't be negative. And then I'm going to divide everything by 2 to the n. And therefore, I've got the sequence I'm interested in, a sub n in the middle, and I've squeezed it between two things. Now, this is just always 0. Okay, but on this one, if I take the limit as n goes to infinity of this thing also goes to 0. And so what I've done is I've squeezed the sequence I'm interested in between two things, 0 and 0. And the only number between 0 and 0 is 0 itself. So this converges to 0. All right, 27. 27 I did in class. So I'm not going to do that one. You can watch the lecture video for that. There was quite a bit involved there. And I believe 28, I did something like 28 in class also. 29, your sequence is 0, 1, 0, 0, 1, 0, 0, 0, 1, and I suppose the next one would be 0, 0, 0, 0, and then 1. So what's happening is every time I go out, I keep on, I'm going to put 0, then a 1, then 2 zeros and a 1, then 3 zeros and a 1, then 4 zeros and a 1, the next one will be 5 zeros and a 1, and that's definitely, this sequence is definitely not going to any particular number. It's going to 0 for a while, then it switches to 1, then it goes to 0, then 1, 0, then 1. Give me just a second. I thought you had class. I thought you had class. Oh, really?
Yeah.
Oh, okay. Because Letty was telling me you came by. Give me just a minute here and let me finish up. I've got 2 more problems to do, if you don't mind. Okay. All right. So the next one, a sub n equals natural log 2n squared plus 1 minus natural log of n squared plus 1. So as, on the previous problem, the answer would be that it diverged just by inspection of the sequence. So here is if we take the limit as n goes to infinity of this sequence, notice this goes to infinity, and then natural log of infinity goes to infinity. This goes to infinity, and natural log of infinity goes to infinity. So what we have here is an infinity minus an infinity, and that is still an indeterminate form. So we got to figure out what's going on. So I'm going to use the property of logs here. Since I have a natural log of something minus another natural log of something, I can turn the two logs into one log with division. And now at this point, if I let n go to infinity, I get infinity over infinity in here. And that I can use L'Hopital's rule on. So what I'm going to do is I'm going to switch over to x, and I'm just going to look at the part inside. Just figure out where that goes. So applying L'Hopital's rule, derivative of the top is going to be 4x. Derivative of the bottom is 2x. These cancel, and you just get the number 2. So what I know is that the inside of this, as n goes to infinity, the inside of this actually goes to 2. And so our answer here is that this converges to the natural log of 2. Whatever that is, that's a number. Okay, the last one. This one's a little tricky. Oh wait, that was the last one. I was going to look at 32 though. I thought that was interesting. A sub n equals negative 3 to the n over n factorial. Okay, so let's try and figure out what is going on here. We know that this thing is alternating because you have a negative 3 to the n power, so it's going to be a negative, then a positive, then a negative, positive, negative, positive. And the bottom is going to infinity. So this is going to infinity, but this is also going to infinity. This one switches back and forth between positive and negative numbers. So let me try this theorem. Let me look at the absolute value of this. If I take the absolute value of this, the absolute value of negative 3 to the n over the absolute value of the factorial is still the factorial. This takes away that negative, so you just get 3 to the n over n factorial. And what I'm hoping for is I'm hoping that this thing goes to 0, because the theorem told us that if the absolute value of the sequence goes to 0, then the sequence itself must go to 0. So if this, then this. So I'm hoping this goes to 0. So let me try it. Let me see if I can convince you of this. This is not a very natural thing. So let me see here. Let me just write out what this is first. 3 to the n over n factorial is equal to 3 times 3 times 3 all the way out, and then eventually I stop. And then n factorial is n minus 1, n minus 2, all the way down until I get to 1. So let me do this for a particular n. Let's say n was 5. Then what I would get would be 3 times 3 times 3 times 3 times 3 over 5 times 4 times 3 times 2 times 1. And so what I'm going to hope for is that I can somehow get some control over this. Notice that this number, right, is bigger than 1. This number is bigger than 1. This number is bigger than, or is 1. This number is smaller than 1. This number is smaller than 1. So those three, I can just cancel them out. So here's the thing we're trying to see here. If I let n get bigger, n be 7, then we're going to have 3, 3, 3, 3, 3, 3, 3 over, and then, let's see, 1, 2, 3, 4, 5, 6, 7. We've got 7 times 6 times 5 times 4 times 3 times 2 times 1. So notice this is where we get the 3's to cancel. These two are greater than 1, right? But these are all less than 1. So what's happening here is what I'm going to do is almost like a squeeze theorem. I'm going to try and get this thing to be smaller than something. So what we need to notice in both of these, there are only 2 numbers that will ever be bigger than 1, okay? And so as I let n get bigger, I'll still have a 3 over 1, then a 3 over 2, then a 3 over 3, except now I'm going to have more of these, and all of these are smaller than 1. So let's see if you can follow me on this logic here. Do you agree with this? Do you agree that 0 is less than or equal to 3 times 3 times 3 times 3 times ... and then I'll have 3 times 3 times 3 at the end, and then n times n minus 1 times n minus 2 times n minus 3, and then I go all the way down to 3 to 1. So we already know that at this point in time we'll have a 1 there. We know these two are bigger than 1. In fact, this is just 3 halves, and this one is just going to be 3. The rest of these, all of these, are all less than 1. So what I'm going to do is this. I'm just going to look at these right here. Okay? If every single one of those is less than 1, less than 1, less than 1, then when I multiply them together, all of these together are less than 1. So tell me if you see, well, don't tell me because you can't tell me, what you think of this. 3 over n, which is the very front, I didn't touch it, times 1 times these two multiplied together, which would be 9 halves. Do you agree that this is bigger than this? Well, 3 over 9 is this, 3 over n is the same thing as this. 9 over 2 will always be these first ones. And then all of these we said were less than 1, so if you multiply them together, they're less than 1. So all of that, if that's smaller than 1, then if I put a 1 here, that's bigger than all that. And this is real nice because we can just multiply across. We get 27 over 2n. And so this over here, this side is 0. And if we take the limit now and we let n go to infinity, this right here will go to 0. And that means the thing in the middle that we are looking at must also go to 0. So the answer is that it converges to 0. Okay, when I do the video for the homework for 8.2, I will do the last problems out of this section, which are 37, 38, 39, and 40. I didn't really get a chance to cover that in lecture, so you'll just have to wait. I'll try and get that video out tomorrow morning.